Hi friends, welcome to the Unit 5 Day 1 Notes. This one is, the Unit 5 is about systems of equations and also systems of inequalities. We're going to start with kind of review. This is the linear system in two variables, and then we're also going to do some word problems. So a system of equations is just a set of two or more equations for which you want to find a common solution. If you think about in real life, if you have certain scenarios that you're trying to find out, you want to combine all those scenarios together to find one solution. So if I'm looking for, say, a group of students that meet the criteria to be in this particular class, to be in college algebra, well, then I'm looking at a very specific set of students. I would want to find students who did well on the ACT or the AccuPlacer, students who are not freshmen or sophomores. To be a junior, there's even additional requirements. There's a lot that's going on to be in that. So this is kind of an idea, a real-world example of where you're using these systems of equations. So we're going to show you a system of two equations and two variables. Notice that on the left here, we have a left brace. This shows that both of these are part of the same system, so we want to find a common solution between both of these. By graphing, we could find the intersection, and the intersection point is the solution. And then I'm saying, okay, go ahead and verify that this solution, 150, 350, is a solution to this equation. So to do that, you just plug in these values for A and these values for C. Notice it didn't give X and Y, it gave A and C. If it gives you a solution, assume that it's in alphabetical order. So to verify, we have to show it for both. So I'm going to do 150 plus 350 is equal to 500. That is in fact true. So 500 does in fact equal 500. So check. And then for the other one, I have 9 times 150 plus 5 times 350 is equal to, oops, I did not include the 5 there. I apologize. 350 is equal to 3100. So 9 times 150 is 1350 plus 5 times 350 is 1500. And that does in fact equal 3100. So that is a solution. So I have verified it. When we solve systems graphically, we're going to find where they intersect. You know about solving graphing, substitution, and elimination. Remember, slope-intercept form is that's our y equals mx plus b. M is the slope, b is your y-intercept. So we're going to convert this to slope-intercept. So 4x minus 3y equals 9. You know that you would subtract 4x on both sides and then divide by negative 3. So let's see, if I subtract 4x first, I'm just going to go and rewrite the whole thing. Minus 3y equals 9. So subtract 4x, you get negative 3y equals negative 4x plus 9. Divide by negative 3, you get y equals positive 4/3 x minus 3. So if I graph that line, my y-intercept is at 0, negative 3, and my slope is 4/3. 1, 2, 3, 4, 1, 2, 3, 2, 3, 4, 1, 2, 3, 2, 3, 4, 1, 2, 3. And then connect them using a straight edge. There we go. So that's for that first one. For the second one, it's a lot easier since all I'll be doing is just adding 2x on both sides. So this gives me y equals 2x minus 5. So 1, 2, 3, 4, 5. So 2, right 1. There we go. Very similar slopes. If I connect these, so that point of intersection is the solution. So that point there is what makes both systems true, which is 3, 1. So if I plugged in 3, 1 into either of these, then I would get that it would be true, and remember it has to be true for both. So that's the solution to that system. So there's some limitations with using graphing by hand. So graphing using technology is a lot easier, but graphing by hand, there's other issues. Non-integer solutions are very difficult to spot. So substitution, you convert it so that one of them is written in terms of the other. So for this example, it says y equals x plus 2. So I'm going to take this y, so this x plus 2, and substitute that in for the y in the other system. So then we can solve it by then doing back substitution. So this is what I just did right here, these steps. So I solve one of the equations in terms of y. So here we have y equals, and then I substitute that in for the other equation. So this is going to be 4x plus x plus 2. There's no coefficient here with this y, but if there was, you would distribute that number as well, equals 4. So then I just combine this. So I have 4x plus x is 5x. 5x plus 2 equals 4. Minus 2. I get 5x equals 2. Divide by 5, and I get x equals 2/5. So now, if I substitute this in, it's easier to substitute it back into the bottom one. So y equals 2/5 plus 2. So that's going to give me 2 2/5, or 12/5. So then this solution here is 2/5 and 12/5. Notice I'm writing it as an ordered pair. If I was to graph these two and find where they connected, that's what they would be. Most often, your calculator is going to convert it into a decimal when it gives it to you on your graph. So if I was checking this, I would need to also convert these to a decimal to check as well. Before we start the next video, I just want to talk about a kind of a notation thing. When we solve systems of equations by elimination, we write them in standard form. That's ax plus by equals c. And then we will use this notation. So R1 denotes row 1, and then we use R2 to denote row 2. Should say row 2. So I will see you in the next video. Bye.